innovation impact and indispensable data at national scale. Just a quick bio introduction for Wayne. As Director General of NHS, he has over 340 staff and is the Federal Administrator of the National Hydrometric Monitoring Network, and is responsible for operating over 2,000 water monitoring stations on rivers and lakes across Canada. Dr. Jenkinson received his master's degree from the University of British Columbia and his PhD from the University of Waterloo. Before joining the NHS in 2021, Dr. Jenkinson spent 5 years advising the Canadian section of the International Joint Commission, IJC, and directing activities relating to water level management, water quality, and numerical modeling in transboundary regions. Prior to his time at the IJC, he was the Senior Research Engineer and Water Resources Lead for the Ocean, Coastal, and River Engineering portfolio at the National Research Council of Canada. Dr. Jenkinson is the Hydrological Advisor to Canada's Permanent Representative to WMO, Cecile Siwa, and is past President of the Canadian Society of Hydrological Sciences. So with that, Wayne, please take it away.
Thanks, Tom. Thank you, Tom, and thanks, Frank, for inviting me to speak today. As mentioned, my name is Wayne Jenkinson. I'm running the National Hydrological Service. Today, I'm just going to provide a presentation. It's not dissimilar to a keynote that I gave at the Canada Water Resource Association conference a few years ago. The goal today is really to talk a little bit about the data that we produce here at the NHS, its value, its importance, and some of the challenges we face, not only in the provision of the data, but in the intersection between our work and work that many of you are involved in at CMOS. So I'll just advance the slides here. It's an overview of our discussion today. Again, we'll talk a bit about water data in the Canadian context. Mostly we're talking about water quantity data today. That's the purview of the NHS. We'll explain a bit about my organization and what we do, some of our challenges, and then talk about the use cases, the importance of the data that we produce and how it's used in Canada and elsewhere. The challenges are many, but we see opportunities and next steps to overcome those challenges, and we'll close with some discussion. About 30 slides or so, maybe 25 with content. We should have tons of time for us to have a discussion afterward. So water data needs in the Canadian context. So clearly, the environment has been changing, literally, I guess, and fiscally as well. We know that extreme events have been one of the most severe global risks over the last 10 years. There are many reports you can point to identify those risks. The demand for data to respond to those risks, to understand how the climate is changing, to understand how we can adapt to those risks is only increasing. And the need to strengthen the environmental data that's available and the prediction services that are supported by that data, both for flooding events and long-term drought response and just water resources management, sharing of that resources is important. We have a little timeline here with major events really only in the last 5 years. I probably could have added 1 or 2 more since 2023. But all this to say, the events that we're seeing across the country, both in terms of meteorological and hydrological events, are increasingly frequent and increasingly unprecedented. And our ability to respond to that with good data to understand them and respond to them is real. If we focus specifically on water itself within Canada, we have some challenges in how we understand and manage those water resources. And some of them are natural and some of them are jurisdictional, how we organize ourselves, and others are man-made in the sense that we have a changing climate that we're dealing with. Important to realize that within Canada, we have jurisdictional challenges. The provinces and territories really have the responsibilities for managing water resources, as per the Constitution Act and other, acts that were signed at the formation of the Federation. And it's only through other legislation that we can act collaboratively in the sphere of water within Canada. These include acts like the Canada Water Act, which I'll talk a bit more about later in the conversation. We also have boundary waters treaties that guide us on how we can share our resources with our American colleagues, other international agreements. And then real gaps in terms of the incorporation of Indigenous legislative representation in some of these instruments. Geographic challenges. Our country is enormous. Our population is relatively small. The geographic variability from a hydrological point of view is huge. Getting a handle on it can be extraordinarily challenging and very expensive. Many of our regions are remote, unpopulated, hard to get to, hard to monitor. And the resources that we have, although we're rich in water resources, characterizing them, measuring them, is very challenging. The changing climate is becoming an increasing problem for us, especially in Canada and in the north. We are warming at twice the global rate and 3 times that rate in the north. And the extreme events, as I mentioned earlier, are really changing how we manage this file, the water file, and the costs associated with mismanagement are real and very expensive. We'll talk a bit about water data user needs. This is something we're very focused on as the Water Data Authority. It's important for us to have a good understanding of what people need from us in terms of water data and who uses that data. This is part of a study that we undertook recently to understand really what the needs are and who our client segments are. But really, our bread and butter is the level and flow data and the metadata associated with it. Really, what levels and flows do we see our lakes and rivers across the country and reservoirs? The need for data is changing. The push for real-time data and really response times that are earlier and earlier is growing, just to try and respond to some of the flooding needs. But there also is needs for daily and long-term historical data to do the analyses required to understand how we design infrastructure and how the climate is changing. Predictions are needed, not only meteorological predictions, but hydro predictions, and not only seasonal flow predictions, but very, very short-term flow predictions as well. And a lot of demands for analysis, not just the raw data, but interpretation of that data in terms of statistics, natural flow calculations, and other trends. I'm not going to go through the client segment list. The presentation's available, but just for your awareness that we have quite a number of client segmentation or client segments that demand and need our data, to deliver on their own mandates. These include governments, land and resources agencies, and companies. Transportation is, of course, very important. Insurance industry pays close attention to our data as well as others. So the data is not just finding its way to other government departments, but really there are many users that pull our data to deliver on their own mandates and their own needs. So I'll pivot now to talk a little bit about my organization, the National Hydrological Service. Some of you may be familiar with us, some of you may not be, but just to give you a sense of how we play in this space and how we deliver on our mandate. So a little bit about us. Two parts of this slide, which give you a sense of who we are and where we're based. So we are part of the federal government of Canada. We fit within Environment and Climate Change Canada. And I'm sure that everyone here on CMOS will be quite aware of the Meteorological Service of Canada. So we are one of the directorates that lives within the MSC. So we're very closely linked to some of the groups that you might be working with very closely or familiar with. Certainly Prediction Services, but very likely the Monitoring and Data Services Division, and the prediction focus CCMEP. By the numbers, Tom already mentioned this in the intro, but we're about 340 staff, many different classification types, mostly technicians, engineers, scientists, but also administrative staff to support a group this large. We're national. We have buildings and offices and warehouses across the country, and roughly a $65 million budget to deliver on this program. We mentioned before, we have about almost 3,000 hydrometric stations that we manage across the country. We personally operate over 2,200 of them. Partners, which is to say provinces and territories and third-party partners, operate about 650 or so. Delving into the NHS in a little more detail, again, you may not know exactly what we do, but most people know the NHS for our hydrometric program, the water level and flow measurement, which has been branded the Water Survey of Canada, been in existence for more than 115 years. So this is probably represents 60% of the work we do, 2/3 anyway. And this is where the hydrometric data gets produced in partnership with provinces and territories, delivering the real-time and archived data for people to use. We are ISO certified, and we work very hard to make sure that our data is of a very high quality. The other third of my organization really is hydrological services, and this is where we support other mandated activities for the federal government related to hydrology and hydraulics. We are leads in the boundary water support for the IJC with the US. We contribute to environmental assessments. We look at oil sands monitoring, flood hazard mapping, a number of projects that really leverage our expertise to support the federal government. But today we're going to talk mostly about the data provision that comes from the Water Survey of Canada, and in some ways where they intersect some of the stuff that's happening within the hydrological services within my organization. So when we talk about the authoritative provision of water level and flow data in Canada, we're really talking about the National Hydrometric Program. It's a pretty special program. It's been in place for over 50 years, and it's a unique federal, provincial, and territorial partnership. I mentioned earlier that water management is a provincial and territorial responsibility, and that stems from the Constitution Act and other acts that were signed very early in Canada's history. How we develop a national program like this requires a mechanism by which we can cooperate. And that mechanism for us is the Canada Water Act. It allows us to set up agreements with each of the provinces and territories to allow us to set up a national hydrometric program whereby we can cooperate, coordinate, uniformly disseminate, and set standards across the country. It's extraordinarily important for us to make sure that the data that we produce is of that national standard, and the Canada Water Act allows us to do that in partnership with our provincial and territorial partners. It is a cost-shared program, so we split costs with the provinces and territories. So many of our, really from the program itself, it's really pretty much a 50-50 cost-share split between the federal and provincial territorial contributions. Pretty unique in the country. We often get asked questions as to how we even allowed this to happen, given how hard it can be for provinces and the feds to get along sometimes. But it's there, and it's been there since 1975 or so, and it continues. And the partners continue to see the value in it. The administration of the program has its own challenges, but it is yielding major benefits for Canadians. Just the images here, that's a map of the hydrometric networks. The stations are categorized, whether they're federal, provincial, or shared. That's mostly linked to who uses the data. And we issue annual reports. So if you were so inclined, we could review and see what the details of this program looks like. How much water data do we produce? We're pretty productive. As I said, we run 2,200 stations ourselves, with another 600 or so being run by our provincial and territorial partners. Those are all available at the Water Office website. About 1.2 million data points are produced daily, and we estimate about 500,000 visitors per month, with peaks at over 1 million during high water periods. The image there is just a map of the real-time data available on Water Office. You will notice a gap there in Quebec. Quebec does not issue their data through our program, through our Water Office currently, but we're looking to arrange for that if we can. So who's asking for detailed water data? Certainly anybody can go to the website and download the data as they need it for their modeling use or their analysis. But often we have questions about the data that we produce, or specific requests for data that isn't normally disseminated. We track these as part of our National Inquiry Response Team, or NERT database. It's interesting because it does tell you maybe those more advanced users, so those users who might ask more important technical questions about the work that we do. And this is just a snapshot over 3 recent years. We can see that the provincial and territorial governments are asking questions all the time, which is normal and expected, but lots of consulting, engineering, and environmental services use our data extensively and look for clarification on what that data looks like. Energy companies like hydro companies, active users, and then the academia and individuals are also quite active users. So these are requests that come to us for clarification. So it's a snapshot of the advanced users, if you like, or those that have particular interest in the data that we're producing for them. So it's an active community, and one that relies on our data very closely. I mentioned this challenge before, in that we're a large country and it's difficult to measure everything with the resources and the time that we have. We are aware of this. You may be aware that you might be aware that WMO has set up guidelines for monitoring both meteorological and hydrologic. our guidelines, I think, came out in 2008. We did an analysis against those guidelines in 2013. The long and the short of it is, of the subbasins in Canada, really only 12% or so meet our guidelines. Another half don't meet the guidelines, are poorly gauged, and a full 40% almost are entirely ungauged. Really, it relates to the size of our country and the difficulty of accessing every area, but it is a challenge for us. We've done an analysis to see, what areas are we supporting and which are we not. By nature of the network, we're supporting populated areas very well. You'll see that most of the stations are in the south, where you'd see more population density, and really areas that are associated with natural resources and natural resource extraction. Where we perform less well in federally mandated interests is really characterizing climate change impact and adaptation. Certain Indigenous communities do not have the densities we'd expect, and the cryospheric investigations and modeling tend to be not well identified. This tracks, given that the remote areas are, and northern areas tend to lead to the points that we have there on the right in the middle graphic. But it remains a gap for us that we continuously try to fill. The two maps there, one is the WMO guidelines assessment from the paper in 2013, and the network risk analysis there is on the right, showing really where where it's colored where we have a few stations or we're not meeting the risks associated, the risk themes identified in that list there. So those are some of the challenges, or I guess that characterization of the needs. I'd like to share with you today some of the challenges we have in collecting the data that we provide to you and to others to manage our water resources in Canada. And some of them are quite interesting. I'll go through a couple examples here that characterize really some of the challenges that we're dealing with. I'll refer to the Calgary flooding in 2013. So some of you may remember, some extraordinary flooding happened in and around Calgary in the Bow River in 2013. Severe flooding, very expensive, $6 billion in damages. And not only is the event expensive itself, and the damage associated to our assets can be quite extensive, but the time it takes for hydrologists and for hydrotechnicians to bring these systems back can be decades in length, or a decade long. So for our impacts, we certainly lost a number of stations. These all have to be rebuilt. It's very, very expensive. But then we have to reestablish the rating curves that we use to generate those flow estimates, and that can take a very long time. So unlike some weather events where the weather event passes through and we have our temperature stations and other met stations back up, it can really take many years for us to get the data back to a way that we're comfortable with after we have these major events. So it's a long recovery and an expensive recovery. And for us, it took us probably 10 years before we could say we were back to normal in that region.
Wayne, sorry to interrupt. You seem to have shared two screens. We've also got an image of a beautiful waterfall on screen share.
Oh.
Could you just
try to share again? Sure. I did not know I was doing that.
Maybe
I'll stop sharing and I'll share again.
All right, yeah. Now you're sharing your.
This is not my screen. So
okay, all right.
That's Don. It seems like Don Conway is sharing your screen.
How do I get rid of that? I've never had this problem before.
Yeah, I think Dawn shared her screen just to unshare.
Oh yeah, let me. Yeah, got it. Okay, sorry about that. That's why Dawn is complaining. Now you should be able to share yours again.
I will try. Give me one moment here.
Yeah, unfortunately,
It
Zoom
was a
only
beautiful
offers.
picture, Don, but yeah, I didn't. I will do this again. Hopefully, this will be fine.
Yeah, if you should be able to.
All right. Minor delay, and we're back in business.
That's better. Yes. Okay. Sorry.
That's good.
No problem. If that works, that's great. I'll continue.
Yeah. Okay.
So I'll go through these a little quickly, recognizing we're 20 minutes in already. This is an interesting slide for us. This is the Okanagan Basin in 2018. Is it a flood year or is it a drought year? Normal hydrological patterns have changed and continue to change. Where we used to rely primarily on, that floods could arrive in the spring, at particular times and particular intensities, this world is changing. So we're seeing more rapid snow melts because of a changing climate, sometimes more snow accumulation, depending on the region. They come earlier, they come faster. So in this particular case, in the Osoyoos Basin, we had flooding in the town of Osoyoos at the beginning of this season. So another wet year in the Okanagan Basin. But then we proceeded to have no precipitation for the rest of the season. So what was a very wet spring turned into an extraordinarily dry summer, and then we had forest fires in the basin. Both of these are extraordinarily challenging for us in terms of water management. It's expensive. How do we manage with fires is its own discussion. But if you were to average the flows of this year, it might be an average year. It's anything but an average year, right? And we're seeing more and more of these hydrological shifts across the country, and our ability to respond to them is challenged, given these intensities. Changing winters are affecting us as well. Historically, we had stations in the prairies in particular that would freeze up and stay frozen all winter. So we would basically stop visiting them. We wouldn't need to manage them much any further during that period. And when the snow melt came, when the freshet came, we'd open them up again. That paradigm has shifted entirely. We can't rely on these stations to stay frozen all year. It just doesn't happen anymore. The questions that we have to ask ourselves now is, how much more service do we need to provide these stations to get those flow measurements when they have midwinter melts? Can we be resourced to do those? What are the consequences of not capturing that data to properly understand climate change? It's a challenge not only in the prairies but everywhere. So again, the weather wreaking havoc and the changing climate wreaking havoc for us. And then finally, another challenge. We're seeing that unprecedented events are causing all sorts of catastrophes all over the country that require water data information. This is an example of the Chilcotin River landslide of 2024, just last year. Massive landslide, blocked up the Chilcotin River, a kilometer long, 600 meters wide, 30 meters deep, and pounding water behind it. We knew it was going to breach, but we didn't know when or how much water. So we deploy temporary gauging stations and crews there to measure those flows. That BC Forecast Center, in this particular case, can understand what that risk is and model the flood wave when it finally does breach that impoundment. Really great success story. We managed to get people out of the way of these flood events, but it points again to the changing environment and how challenging it can be to meet the needs, the water data needs of our partners and really of Canadians. So establishing value. So I'm going to speak a little bit about how these data get used. I intimated at it in the previous slides, but this is really the downstream users of our data and the important role that this data plays in supporting Canadians. Certainly, we have support for flow forecasters. Although the provincial and territorial flow forecasting teams, they have the responsibility for issuing warnings and alerts. Our data is critical for them to be able to do that work. So we have a very strong relationship with the provinces and territories to ensure that our data is available in a way that they need it, at a time that they need it, to issue their forecasts effectively. Many provinces, some listed here, have their own flow forecasting centers that they run. Many provinces don't have those flow forecasting centers and just rely on the real-time hydrometric data to inform agencies and inform the public of risk. So we continue to work with the provinces to ensure that they can advance their prediction services as best they can, and also to support hydro companies, because they rely on their forecasts to optimize their businesses as well and to ensure public safety. We provide support for drought characterization. The provinces and territories and the federal government all employ our data to properly characterize, the nature of drought severity with the stream flow and water level data that we provide. So the different jurisdictions have different approaches, and the NRCan helps bring that data together with drought monitoring products. But again, critical data for Canada to understand how we manage droughts, which can often be more expensive in terms of overall economic costs than the floods that we deal with. We support transboundary water sharing agreements. So, both internationally and provincially, the way we share water, the way we use water collaboratively within the country and with our American friends relies on good hydrometric data to ensure that we're sharing these data effectively. Probably our biggest domestic board that we work with is the Prairie Provinces Water Board, and there's a master apportionment agreement that dictates how water is shared between Alberta, Saskatchewan, and Manitoba as the water moves west to east in most cases. We have many stations that help drive those calculations. But also, and as importantly, certainly is the work we do with the IJC to ensure that our hydrometric stations and international gauging stations ensure that we are sharing water effectively, that our shared infrastructure that we have with the Americans is being operated correctly, and that any risks associated to stakeholders in these basins are properly assessed. So very important to have this data upstream, so to speak, for these types of activities to ensure that our Canadian water security is maintained. We support flood hazard mapping. This is an initiative I wanted to share with you. It's called FIMP, or the Flood Hazard Identification Mapping Program. Again, these sorts of initiatives are largely provincial and territorial in nature, floodplain mapping, flood risk assessment, but coming up with national standards is important, and providing tools so that these maps can be done is it both a provincial, territorial, and federal interest. This is a project that we've been a part of for many years now, really looking at ways to map floods in key locations so that these analyses can be used for provinces and territories to really do their own planning and protect citizens. And finally, in this section, just support to the international community. So we provide, as Tom mentioned, I'm the hydrological advisor for Canada, and we are, I guess that puts us in a position of leadership for Canada in terms of our contributions to the WMO. So we provide data, certainly in support of the now quite popular, I understand, State of Global Water Resources report that gets issued every year. This report, the 2024, was just released a few weeks ago. So our data is important, as is the data from all countries. But we also provide expert support to WMO with many of their committees, as we, both in support of the regional associations, North America and South America, expert teams on hydrology, looking at Arctic and polar region analysis, cryosphere, and coordinating on hydrological activities within the WMO. So we have an important leadership role there, but the data, of course, is part of that. I'll also say that we do lead a webinar series in partnership with our USGS colleagues, US Geological Survey colleagues, to advance best practices in hydrometry, really in North and South America, and now, I guess, all over the world. So we are taking the Canadian expertise that we have in this space and trying to ensure that other member countries within the WMO can take advantage of that, and we're doing that actively. So we'll talk a little bit, this is sort of the penultimate section here. I'll talk a little bit about opportunities and next steps for us. And they should line up, I think, with some of the challenges you've heard me mention, both within the organization in terms of how we work and within Canada writ large. So the NHS is committed to innovating to better deliver on our mandate and to try and improve how we deliver data to all of our stakeholders who need it. As I mentioned, we have a very large country. It's very hard to monitor every river and lake. Some of the conditions that we have our techs in, the water level conditions can be quite high. It can be risky for them to be in the water when these happen, which might compromise our ability to collect data. We are constantly innovating to try and find ways to do things more effectively, more efficiently, and to really add value to the program. So we're partnering with USGS, academics, and others to develop new technologies to supplement or replace our current approaches. We're using radar on rivers and other index velocity measurements to sort of try and capture velocity estimates when nobody's there to do those measurements themselves. We're doing a better job of incorporating uncertainty estimations into our products. Capturing flows under ice is important in Canada. It's extraordinarily tricky to do, but we're developing techniques to allow us to do that. Station cameras, as simple as they sound, are extraordinarily valuable to characterize the conditions and to share that with our partners, but also to try and understand, what's happening in terms of the flow in those locations. And finally, artificial intelligence, it's moving quickly. We're doing our best to keep on top of the advances, but we're already seeing opportunities for us to accelerate the interpretation of our data and approval workflows within the hydrometric sphere. So our goal, as stated here, is to improve our data quality and add value to the program, really maximizing the limited resources that we have to monitor such a large country. This is probably interesting for many of you in the CMOS community. We have developed and continue to develop national scale hydro prediction services across the country, and this is relatively new within the last 5 years or so. We are leveraging, if you like, some of the excellent meteorological prediction work that's being done within the MSC to advance that to provide really national products that give us good estimates of hydrological conditions across the country. So the product is called, or one of the products is called the NSRPS, or the National Surface and River Prediction System, which estimates flows across these basins that are identified here. This is an outdated image. There are more basins that are available now. But this is done in close collaboration with the provinces and territories so that they can use this data in their own applications. As I mentioned before, it's their responsibility to issue floods and flood alerts and warnings. It's important that the products that we produce within the MSC align with their operational needs. So there's a community of practice established to ensure that we know what their needs are. We can guide our research and development and product development to best meet their needs. It's a big country. The needs are different, but with this engagement exercise that we have a good chance of providing product to those, especially those provinces that have very limited flow prediction capabilities. So it's also our hope to leverage these within our own operations. If we have good hydro prediction estimates at our station locations, it can mean more efficient site visit timing. It can also mean, increased safety for our staff. Space-based Earth observations are an important part of what we're trying to do here. This is, we think, the future of what we're trying to accomplish with NHS. Our country is big. It's impossible for us to be everywhere. Space-based Earth observations provides hope that we may have better estimates, at least for our larger lakes and rivers, to understand what the levels and flows are there. So the SWAP mission was launched a couple of years ago now, the Surface Water and Ocean Topography mission. We have been partnering with the USGS and others to try and run site validation studies to ensure that the data can be used, or to calibrate that data for eventual use. We're hoping that this mission will become operational and we can look to eventually migrate these data into our suite of data we can provide to the public. Right? So the Terrestrial Snowmass mission, this is a planned mission that Canada's leading. The goal of this mission is to really deliver better quantification of snowmass on the ground. Lots of applications outside of hydrology naturally, but I think for Canada, and for any hydrologist will tell you this in Canada, better characterization of snow water equivalent will improve our ability to forecast freshets, and so that it's such an important piece of information that's hard to capture in Canada. We're hoping that mission and others may provide some answers on how we deal with the sheer scale of the Canadian hydrological problem. And then finally, penultimately, I'll mention that Indigenous partnerships and collaborations remain important for us. We are on the ground interacting with Indigenous communities as we visit our stations. In the work that we do in transboundary basins, the role of Indigenous partnerships is very important. We had an evaluation internally recently, and one of the recommendations was looking at how we could better work with Indigenous communities going forward. It's critical. And I think some of the changes happening now, including the formation of the Canada Water Agency and their commitment to look at the Canada Water Act and integrate Indigenous concerns for water in Canada, I think are going to go a long way to improving how we collaborate going forward. So we're very excited about this. We're already very involved, as I mentioned, in the transboundary work with the IJC, and by virtue of the fact that we're often on Indigenous communities, doing hydrometry. But there is more to do. I think we have found that in the work that we've done supporting the IJC, there's lots of opportunities to work together with Indigenous communities to take Indigenous knowledge alongside Western knowledge and develop very interesting studies and bring them along with us. And then the last slide I'll present here before we go into discussion is just to highlight a report that came out recently that some of you may be aware of. The Council of Canadian Academies issued a report just September 11th. It was released. And this was really looking at, and it's titled "The Future of Hydrological and Meteorological Services in Canada." There's a lot in this report. I'll admit that the focus is primarily on meteorology and meteorological forecasting, but They certainly do highlight some areas that intersect with hydrology and hydrological prediction. I'll say I think the report is probably missing some things to my view. There are things that I would have liked them to investigate that they didn't. But what they did identify, which I think is relevant for us, both those of us in the water world and those of us in the atmospheric world, is that there are gaps. And I think those gaps occur at the intersection between our specializations, so in the hydrology world, in the meteorological world, as well as gaps that occur between our jurisdictional responsibilities. So that includes the federal, provincial, municipal jurisdictions. And in those gaps, there are opportunities and there are risks. So what this report highlighted, that really affects my work and the work, for those of us involved in hydrology, hydrometry, and flood forecasting, is they flagged that there are no flash flood warning systems currently active within the country, and that there's a fragmented approach provincially on how those types of floods are addressed. So the call in this report really was for leadership in the development of a national flood warning capabilities, and that there are opportunities for us to leverage new technologies, AI, remote sensing, et cetera, and leveraging international models to close that gap. So we don't have to cast our minds too far back to remember the Fiona and the flash flooding that happened in Nova Scotia and Quebec and the lives that were lost there. This report, although not complete, I guess, in the work that they have done, I think in terms of assessing some of the challenges in hydrology going forward, it does highlight an important message for us, namely that some of the boundaries that we have given to ourselves between the meteorological and the hydrological are not real, and one that we should work actively to breach, and that in our role as the federal leads in the Meteorological Service of Canada, we have a role to play to bring the Federation together on how we address some of these challenges, which really are very difficult for some to solve, especially some of the smaller jurisdictions. So yeah, I think maybe that's a message of collaboration now and going forward that'll leave us with today. And with 20 minutes left, I'll turn it over to discussion. So over to you, Tom, I guess, and Frank.
Well, thanks, Wayne. That was a fascinating overview for an organization that has been around for a long time and at the same time very, very modern in its outlook. So with that, I'd like to open up to questions, both in the chat and if anybody wants to raise their hand or ask a question, please go ahead.
We have nothing in the chat at the moment, so if anybody can join with the discussion, just turn on your microphone. Thanks.
Maybe I'll just start with one, Wayne, there. Of the issues with the IJC, so there's a number of issues there. Is navigation the main one? Obviously, water volume. What are some of the sticking points there?
Yeah, so I think, often when we talk about some of the challenges with the IJC's mandates vary across the transboundary. So depending on where you are, the orders in place or the direction that's given to the IJC can differ. So just by way of illustration, that I mentioned some of those transboundary areas in Alberta and Montana, for instance, the primary issue is water sharing. It's an arid area. They want to make sure they share those waters. But if we look further east to the Lake Ontario, St. Lawrence River system, there's an order in place there that directs the IJC to regulate levels and flows in Lake Ontario and St. Lawrence River. And one of the primary stakeholders is the St. Lawrence Seaway. So navigation is key. It's a key factor in how decisions are made in terms of managing water levels in that binational system. So there is interest, of course, in keeping the Seaway open. It's worth many millions of dollars as these ships move up and down the St. Lawrence Seaway. But that interest is balanced against other interests like the flooding of riparians, water availability, there are ecological considerations as well. So absolutely, navigation is an important element. It's actually mentioned explicitly in the Boundary Waters Treaty. But how those interests are considered really depends on where you are and what what needs to be considered, and certainly transportation is a big issue in this Lake Ontario St. Lawrence River Basin.
Yeah, I think that's great. There is a question online in the chat. What about flash drought characterization and early warning of flash droughts as well as flash floods?
Yeah, it's a good question. I mean, I don't hear the word flash drought as often. We're currently experiencing extraordinarily dry conditions in the West, and that's been something that's been accumulating for a long time in the Prairie region and continues to this day. It's a good question. I guess when we talk about the challenges with flash flooding, it's really about getting, and these are, I'm borrowing expertise that isn't my own here. So this is stuff that we hear from my colleagues within the MSC, but developing the meteorological tools that have a real a resolution and a timeliness that allows you to properly characterize intense rainfall, and then on the ground a good sense of what those forecasted events will mean in terms of quick hydrological response, like the ones we see in Toronto, even this week, and Montreal not that long ago, and really all over the country. Flash droughts, I don't have as much experience with that, but all is to say that if we have accumulation of dry conditions, the impacts can be severe, and characterizing that both seasonally and in shorter term can be quite important. So.
Okay, great, thanks. Follow up on the Quebec data issues. How's that being solved?
Yeah, it's a good question. So it's interesting. We're in discussions with them now. Quebec has taken a bit of a different approach within the National Hydrometric program. So whereas generally speaking, the Fed's NHS Water Survey will do most of the field work, in Quebec, they've opted to do most of that work themselves. So it's almost an inverted relationship. Instead of us doing the work for the partners do the work for us. So, and it's just, since I've been in this position for about 5 years, the status quo has been Quebec doesn't provide the real-time data to the Water Office platform. And part of it is, I think, a concern that there will be duplication of effort, or where will the authoritative source be for the water data that's available. I think it's a solvable problem. I think we can probably make some arrangements to bring them on board. I think it looks strange to have the map and not see Quebec on there, given that they are active participants, and we work very closely with them. So what can be done? I think there are several ways to solve the problem. My team's actively working on that now. So.
Okay, great, thanks. I don't see other questions for one, but there was a number that you mentioned, 40% ungauged. Are there plans on gauging that in the future, or is there?
It's a good question, right? So I think, hydrologic networks are expensive in the sense that, we do require regular visits. Flow measurements have to be taken. And that usually, requires generally human beings to be there to do those measurements, not always. So they're expensive. And I think, the WMO analysis, if you follow that to the letter, it would basically mean a tripling of the size of our network approximately. So we need another 5,000 stations to do that, and we just don't have the budget to do it. So if you give me the budget, Tom, we'll do it tomorrow. But I think the challenge we have is just that we're never going to get there. The question is, how do we optimize our network so that we're getting as much data as we can, providing as much information as we can to the people that need it the most, I think. And so we're a massive country. I think some areas just will never be gauged. And that's an aerial estimate based on sub basins. So it's a standard delineation that we have for watershed basins in the network. So it's hard to characterize exactly, but yeah, I think we would love to have more presence in the north. That's where we see a lot of the climate change and the risk. Certainly, there are Indigenous communities that would relish having some more stations nearby. And I think just to characterize, some of the cryosphere challenges that we have, not only in the north, but in the Rockies and other areas that need better characterization. I think we would love to head there. I think what you're seeing us do, Tom, is look at other technologies that are allowing us to free our time up to do more, really. So with these automation techniques, with AI, with new techniques for at distance measurement of index velocity
based observations as well.
Yeah, maybe there are ways that we can get more information without necessarily just scaling our current operations. So it's a challenge, but we're looking at heading ourselves in that direction.
Thank you. Any other questions here? Or should I pass it back to Frank? Don't see anything else on the chat either. But thank you very much, Wayne. That was really
absolute
interesting.
pleasure.
Yeah.
Absolute pleasure. We'll make sure that the CMOS can come and present at the Canada Water Resource Association soon.
Yeah. Well, you've certainly given us enough to think about and ponder. We will be putting a recording of this onto our website, and you have kindly given your email address on your last slide, so we'll may take that up if we have further questions. Thank you very much, Wayne. That was very helpful.
You're absolutely welcome,
Interesting.
Frank. And
Excellent.
we'll happily do this again anytime on another topic. And I think too, just happy to see our worlds intersect more. I think there's opportunity for us if the closer that we work together on some of these really sticky challenges with Canada.
Yeah, it's certainly an interesting time to be in this field, that's for sure.
It is. Thank you so much.
And thank you everybody for attending.
Thank you. Goodbye now.
Thanks. Right. Bye.
Yeah.